Greetings all, Kirk Reed with Werewolf Welding coming at you again this morning. I'd like to start this video by saying, number one, I was not intending on doing this video so soon. I was gonna try to wait till the surgery was done on my jaw and go ahead and do it then, but because of the fact I was asked by several on Facebook yesterday to please hurry up and do this video, I'm going to do it this morning. I'll struggle through it, and I hope everybody can understand everything I say, and I'll try to make the best of it, try to make it as clear as possible. This video is going to be on TIG welding consumables, in particular collet bodies and nozzles and collets and gas lenses. Some good rules of thumb to follow, and I'd just like to say that there's a lot of information out there on YouTube. There are a lot of other good websites. Some focus on motorsports welding, some focus on heavy fabrication, but it doesn't seem to be that there's a lot that focus on just everything in general and some good rules laying down. I'm going to cut away from myself in just a minute. I'm going to show you some of the different types of consumables. So you won't see me, you'll see the consumables, and you'll see me pointing out what they are. Here we go. First of all, we have a number 7 or a number 17 air-cooled torch. I have the cigarette lighter beside it to give you scale. This is a standard length. This is the collet for it. Here's a prime weld number 7 stubby with a gas lens for the 17 torch also. Both do pretty much the same thing. Here we have a clear Pyrex number 7. Does identical to what this does, except you can see through it. It helps you when you're in tight corners see your arc somewhat better. Beside it we have the number 16, which is generally considered, you use it for chrome moly, you also use it for titanium. Number 12, Pyrex. Once more, I like to use that for stainless steel and your exotic nickel alloys. Here's a number 5. That's for light aluminum. And here's the smallest that we have, and I believe probably one of the smallest they make, which would be a number 4. Now, cutting back to me, your number on each one designates the opening of it. It's given in 1/16 of an inch, so a 16 would be 16/16 or 1 inch inside diameter. A number 7, there again, is 7/16 of an inch. Why is this important? It's important for several reasons. Number 1, when you're setting up your stick out, whatever the number of the nozzle is, your stick out should be equal to that. So a number 7 nozzle, you would want 7/16 of an inch stick out. Yeah, you can go just a little bit more, you could go a little bit less, but I've found over the years it's best to pretty well stick with the manufacturer recommendation. Now, the other thing that it does, a number 7 helps designate the amount of gas flow. You should have 2 cubic feet per hour gas flow per every number on the nozzle. So a number 7, you would want 14 cubic feet an hour gas flow. Now, there are certain conditions that you would want to raise your gas flow a little bit. The maximum would be 2.5 cubic feet per hour. per numerical designation. So, with that being said, those are some pretty good guidelines to go by. As long as you follow them, you'll always stay in the ballpark. Yeah, it blows people's minds, a number 16, your 30 to 45 cubic feet an hour gas flow, and you can actually run it up to about 1.25 inches stick out. Do I like doing that? No, I really don't. I really, unless I absolutely have to, don't even like using a nozzle that big. I use it on chrome moly on the race car frames, simply when I need the long stick out to be able to get into tight corners on the roll cages in some spots. And I also use it on titanium. Other than that, it just sits in the kit. My standard go-to nozzles, and a lot of people argue with this. For aluminum, I use a number 7. A lot of people use a number 5, say you don't need that much coverage. Well, to a point they're right, but they're normally, when they're using a number 5, they're staying with about a 1/4 inch wide bead. Yeah, aluminum doesn't need a lot of gas, but it does need to be covered on each side. So, if you're only running a number 5, that limits you to no more than a 1/4 inch bead maximum. With the number 7, I can go a little bit larger, and because it's not uncommon for me to weld 1/4 inch aluminum to 1/2 inch aluminum, I need the extra width. Now, as far as tungstens go, the biggest mistake people are going to make, they're going to dip the tungsten as they're trying to weld. Grind it. Do not try to weld with a dirty tungsten. Keep your tungsten clean, keep your tungsten sharp. Now, for the most part, there are 2 types of welding machines out there. There are your older transformer type machine. Your transformer type machines want to use green, which is pure tungsten, on AC for welding aluminum. For the most part, they like a red for all others. I do not like the red. I've used red for 40 years. What I don't like about it is slightly radioactive. So every time you grind it, that dust, if you breathe any in, it's getting in your lungs. It's radioactive. It's actually seeding your lungs. My go-to tungsten is blue, 2% lanthanated. Seems to be very good on my inverter machines. I have sold my transformer machines. I have, for the most part, strictly inverter TIG welders. Don't want anything else. I have used the CK laser tungsten before. It is a good tungsten. The only drawback I find with it is the fact that you're limited where you can get it, and it is slightly more expensive than what the blue is. The blue you seem to be able to buy everywhere. But for the most part, with an inverter machine, it doesn't matter. Just pick a color, whatever your favorite color is, and go with that. For the biggest majority of your TIG welding, I'm assuming will probably be on light fabrication and on automotive. You're going to want to go with a 1/16 tungsten and a 3/32. Now, you can do pretty much anything with a 3/32 that you can do with a 1/16, but you're limited on what you can do with a 1/16. So your best all around starting off is go with your 3/32. like I said, keep it sharp. In the years past with the transformer machines, with the green tungsten, you actually had to ball the tungsten before you started welding with it. With your inverter machines and the adjustability and the balance, you do not ball it, you keep it sharp. It will slightly ball on its own. When it does, that's all right. You just keep welding till your arc starts to wander. Go ahead, grind it again. Now, a lot of people like to use the stubby gas lens, which is what the majority of them I showed you were, as opposed to the standard length collet body and nozzle. That's just personal preference. That does make your torch seem smaller. It allows you to get in some places that you could not get in. Some even suggest that you use a short back cap on your torch, snap your tungstens in thirds, sharpen them up, that way you've got a readily supply of sharpened tungstens. Don't have to go back to the grinder as often. Well, that's all well and good, but when a tungsten gets to a certain length, you pretty much need to throw it away because you really can't sharpen it anymore. You can't handle it. So if you start snapping tungstens, you do end up wasting more of them than if you leave them whole and use a long back cap. Just my experience. I only cut my tungstens down to length when I absolutely need to. With that being said, my jaw is starting to really hurt right now. I'm going to cut this short. I'm going to end it. Thanks for your time. I'm going to hopefully have another video on Monday. It'll be a lot more in-depth, and I will get into how this actually works out for everybody. Thanks for watching. See you later. Remember, like, subscribe, leave a comment, and please share this video with all your friends. Thanks a lot. Goodbye.